Okay, I think we're ready to get started. Welcome, everyone. This is a educator workshop held in conjunction with the Earth Science Information Partners annual meeting. We have broken it up into 3 chunks, and there are breaks during the day, during those empty times. There's food in the morning, food in the afternoon, and there's also a lunch break. So these are all of our speakers for today. In the first session, we have Sabrina will lead us. Then we have the session that I may have poorly named Data Jamboree, but it basically is a number of us sharing resources and trying to have you interact with data. And then at the end, Nick Okafor will have a sort of a workshop like Sabrina in that last session, which will be really wonderful. I guess if you fix it. Yes. We'll start texting someone. No, you're here. And these are our workshop's goals. I just want to remind you that this is brought to you by the Earth Science Information Partners Education Committee, which I will be constantly asking you to think about joining, because we always want to have new members and increase our membership. So our primary goals today, we want you to be able to use data, enhance your ability to work with data. We want to raise your awareness of different tools and data sets that are out there. As much as we can, we'd like to create a collaborative community, talk to each other, share ideas, and have some fun today. And so we'll start with a quick introduction. We want to keep this pretty short so that Sabrina can have most of this time. So if you can just tell us who you are, your affiliation, what you teach, and who you teach, and what brings you here to this workshop. And we'll do this, quickly, and then we'll hear it from the online folks. Okay, so we'll start here. Oh, I suppose I should start, right? I am Carla McCullough. I am the outgoing chair of the Earth Science Information Partners Education Committee. I primarily teach teachers, and I'm here because I'm very excited about all of these data sets and resources there are to share with you. And Dawn.
And I'm Don Haas. I'm the Director of Teacher Programming at the Paleontological Research Institution. It's Museum of the Earth, and it's Center for Climate Change Education. I'm a former high school teacher and professor of science education, but I've been at PRI for 18 years now. And I will also note you might want to pin the ESIP Room 6 owl, which has the view of the whole room so that you can see everybody. And I will also note that it's weird that it's not a mirror image, so it confuses me to look at it. And I will pass it down the table.
I'm not going to unmute.
Yes,
right. Just speak
to the owl. Got it.
Yes, to the owl.
Hi, my name is Yola Smolin Santana. I am a 5th grade teacher of science social studies at Alvin ISD. I've taught kinder, 1st, 5th grade, currently holding the science department head for our school. And I came here because I got the advertisement on CAST. And I was like, ooh, I want to get out of town for reality. And so I was going to do something productive.
Welcome.
But out of town.
Great.
I'm Belinda Jacobs. I'm currently in Georgetown ISD as an instructional coach this year at an elementary, but in the past 4 years in special education, serving both elementary and then also secondary. But for 17 years prior, I did teach middle and high school earth sciences and all sciences at all different levels. And I came partly because I knew people who were presenting and I saw their names flash across, but also because I was like, hey, it's in Austin. I can drive downtown and I can beef up science, put science in my brain again. Because more of my focus this last 4 years has been specifically on pedagogy and special education, differentiation strategies and modifying curriculum. And so it's just kind of nice to just put my science hat back on now that I'm going to serve a whole campus population of all content areas. And I really want to make sure the science is put in there, especially since we have a lot of that real entry level.
Hi, I'm Lalita Kanka. I teach at KDISD. I teach 6, 7, and 8 grade, but I came here because I did a project with my sixth graders, so I was a presenter, so I'm here to present my project. Hi, I'm Chimilina Tavera. I am an elementary teacher in Kremlin, Colorado, and I'm teaching fourth and fifth grade students. I came here because I felt the need, I felt the need that this topic can help in in my teaching to my social studies and science students. Thank you.
Hi, I'm Larry Lawler, and I'm a high school teacher. I teach chemistry and astronomy, and this will be my fifth year of teaching, so I'm still excited to teach. And that's why I came here, so I can learn everything I can to help me and to teach my students better.
Awesome. I'm Kelsey Hulsman. I am the ESIP fellow that is supporting these sessions today, but I also am really excited to be here because I used to be a teacher and I love teaching. It was like one of my favorite things about grad school. And I have taught many a class at university, and I previously taught high school math. But I'm really excited to be here.
So before you introduce yourself, and Nick, if you can hold on for just a minute, can we hear from the online folks?
Do you just should I call on them?
Yeah.
Okay. But not the ones that are here. Eric
Yes.
Walters is not here, yeah?
Eric is not here.
Okay. Eric Walters, would you like to introduce yourself?
Hi, my name's Eric Walters. I'm Chair of Creative Technology at Marymount School of New York. We're an independent all-girls school. I've been coming to these teacher workshops for I don't know how long, but I always walk away with something phenomenal to use in class. So the ability to join virtually is awesome. So thank you for having this.
Hello, Eric.
Wonderful. Let's see. Who else? Sorry. Kathy, would you like to introduce yourself?
Sure. Hi, my name is Kathy McBride. I am a science teacher in Southern New Jersey. I teach grades 3 through 6, and I'm looking for more ways to integrate data into my lessons. It's actually one of my professional development goals for this upcoming year, so the timing is perfect. So I'm looking forward to learning some new exciting ways to implement real-world data into my lessons.
Wonderful. Thank you, Kathy. Breen Rashid, would you like to introduce yourself? Come back to Breen, maybe. Yeah, we'll come back to Breen. And feel free I know Breen said earlier, I can hear and see you. Feel free to introduce yourself in the chat, and one of us here in the room can vocalize it for you if you'd like. Emily Kavanaugh, would you like to unmute and introduce yourself? And Elizabeth Williams, if you would like to introduce yourself.
All right. Hi, everyone. Good morning, still morning. My name is Elizabeth Williams. I am a staff scientist at the USGS Youth and Education and Science program, and I'll be speaking with you a little later today in the Data Jamboree.
Awesome. I can't wait for the Jamboree. Breen introduced themselves in the chat. I teach high school science at Lake Dallas High School, Texas. I teach environmental systems along my other classes. Awesome.
And then I think we have Nick.
Yes.
All right. Hi, everyone. My name is Nick. I am a recipient of ESIP Lab grant. I'm here to showcase the work. I'm based in San Francisco, and I run an org called Drop and Go. And so we're at the third session at 4 o'clock, 4 o'clock Central Time, and we are showing a tool that uses AI to help generate data civics lessons. So based on where you're based, what you have to teach, what standards you may have to align with, it'll generate a lesson and find you the maps, the data sets for you to integrate right into your lesson plan. It's in beta. We just launched like a month ago. And so it'll be, very early prototyping to get your feedback as we bring this tool to get more maps out there.
And then we have our leader today for this next session.
Just for today. I have an intro in my presentation, but I'm Sabrina Ewald. I'm here at UT Austin in the Petroleum and Geosystems Engineering Department, and I'm a former classroom teacher that was hired to do teacher outreach for the department. And I'll be doing the first session sharing our resources and activities and different data that we use.
And then I think the next slide is where we want everybody to land. This is our agenda page that you will want to open, and it has links to a lot of the materials that we use.
And I will say, I have not updated my links yet, but they will be there. So save that page.
Actually, when I went,
We can put it in the chat. Yeah.
when I click on whatever I put in the go here, it doesn't actually go there. It goes to a 404 error. But let me try this.
It's working.
This.
I just
It
put
is
it in the,
working.
I just
Okay.
put it in the chat.
Thank you, Dawn.
Okay.
I think I just probably messed up a letter.
I should have sent it to you. That was my
It's all good, but I'm going to change the link.
trying to type that is reason.
While the online people had a chance to access.
Yeah, it's in the chat.
Okay. So I'll transition.
Well,
It's fixed now.
I love this little bar. Dominator. There we go. Ta-da!
You guys can let me know. Need more time to. We're good? Okay. Well, it's kind of like pressure being first. So welcome to UT Austin's campus. We have a lot of construction going on, but still lots of great things. We actually have a new building we're moving into in a couple weeks. Oops. Okay. This is just kind of how it's been lately. Okay. So I thought I'd just start first with me, just overview. So I was in the classroom for 23 years before I was hired. I've been out of the classroom 3 years now. And most of my teaching was in earth science of some kind. I'm involved in NAGT as well. But I was brought to the university to do teacher outreach. We have a big engineering workshop we do in the summertime. I actually just had 25 teachers here on campus. And since the state has changed our standards to include a lot of engineering, we like to provide classroom resources that focus on engineering design since we are an engineering department. And absolutely everything we do is free. And one of my big roles is ensuring that things are correlated to TEEPS. So to make things easier for teachers to integrate. I will say most of what we're doing now is middle school, high school. I'm the only teacher who is part of the outreach. So my bandwidth right now, doing the best I can and making sure that things are ready to go and we can deploy them during our workshops. But I did spend 18 years as a curriculum writer in my district. I taught North Dallas, first in Richardson, and then Frisco was the last place I taught. I've also been an AP reader for almost a decade, and from once when it existed, which is sad, we built it, the Duke Talent Identification Program. I was an instructor for that for about 10 years. So just lots of opportunity to engage in education in different ways that have helping me with developing teacher workshops and helping bring teachers useful resources. And then I'm gonna have a little bit more information about this later. These Texas Mining Reclamation workshops are open to any teacher in the US. They're also free, and I'm one of their facilitators, and they're a great opportunity to integrate some of those natural resources. So I'm in charge of, this is a newly formed initiative that's called Choose Energy. It's all about choosing an energy career, choosing a STEM career, but of course, choosing to be a Longhorn, because part of this is getting kids information about different opportunities at UT Austin in subsurface energy and things like that. Larry, who's here, and Breen, who's online, has been through a lot of our workshops. But we like to go out to active sites. Like we were actually at a well plugging at the GSA conference. We had a field trip. But we do a lot of workshops here on campus and throughout the state of Texas. And our primary mission is all about energy literacy while helping teachers, because I remember a lot of teachers not having a lot of strength in earth science and energy resources. And so we're trying to provide things that are easy for them to use while also working with the curriculum they have. And so we do this through our big teacher summer workshop, our online content, and then other educator events that we put on. Sorry, I saw that little box pop up. If I'm not speaking loud enough, let me know, people online. I can speak a little louder and project if I need to. But again, emphasizing everything we do is free. And so a lot of hands-on, a lot of interaction. And the great thing is it's all being taught by our faculty. And we also partner with other universities and other entities like the DOE. We have different people that help us build this curriculum and these resources. And so we're getting a lot of experts as we're building this portfolio of activities. But you can see from the list that we have different ways that we're engaging with teachers. These are the two primary faculty that I work directly with. Both have industry experience. Both of them are geologists. John's also an engineer. Hillary's focus was micropaleontology. But a lot of the activities we're doing in the classroom, they've spent decades doing in their outreach. And we're just updating with the new TEKs and, again, deploying with all of the alignment to make it easier. And we do have NGSS alignment for those teachers who were from other states. Like I said, I know the little box keeps popping up, but just to illustrate just the different people that we have involved in our outreach. Some are at the Bureau with Bridget Scanlon. I'm actually working with her on a DOE project with critical minerals and looking at finding critical minerals in the waste stream of fossil fuels. She and Britt Elliott. We have people from Penn State and grad students, just people from all over who help us in building this outreach content. So our goal today is to share with you our main platform, Energy Excursions, which is where we house our free online content and our teacher community with resources. And I'd like to try to do an activity with you guys. It's been a long time since I've done an online, so we'll see how this goes, but it is a data-driven activity in looking at carbon storage, because Put It Back is our mini course on carbon storage. And then looking at seeing the relationship between CO2 emissions and consumption globally with different countries throughout the world. And then doing a wrap up with sharing some other applications, and I actually have other teacher workshops coming up to share with you guys. So this is our main website. Hillary and John and others in that instructors list created this back in 21 or 22. And it started with just many modules of courses written for high school students. So Pursue the Safe Well is all about drilling. Put It Back is our carbon storage course. How much water does it take? Looks at the water energy nexus. So the very difficult situation of the water consumption with energy. So it does not include data centers. I know that's another part because you need energy for data center and then water. That aspect has not been put in that yet. Energize the Future is all about the energy portfolio. So the mix of energy resources. And then energy's hot topic is geothermal. There's a lot of application of petroleum engineering and geothermal with the drilling of wells to enhance geothermal systems. And soon we'll be launching a petroleum geology high school mini course that I'm writing in conjunction with Hillary. But the nice thing about, I think all of them that Put It Back had an engineering design project in the course, and we'll look at those in a little bit. The other great thing is you can search for your standards. So whenever you're on a course, you can see the high school alignment. I would say middle school alignment's not up yet, but everything with NGSS, College Board for AP Environmental, our Texas standards. We do work with Nevada and Oklahoma, so I've also aligned to those two states because we have states that kind of loosely adopt NGSS that still kind of do their own thing. But whenever you open up, you can class it out. You can search for standards with each of the different courses and pages. And please let me know if I'm going too fast. And then a little later, we'll jump into, we have a teacher community, and you can save that bit.ly for later. It's free to sign up. Our community, we have a login that's a way for us to track metrics with our activities that are being used and things like that. As we're looking for ways to find funding to expand what we're doing, entities like to see those metrics. So we have a sign-in as a way of tracking our teacher community and its usage. Eventually, I would like to have some asynchronous PD. We're able to provide CPE hours because we're higher ed per the State Board of Education in Texas. And so eventually in that community, I'd like also to have asynchronous PD. So if teachers can't come to an in-person or virtual workshop, something they can complete on their own.
What does the community entail? Like, what is it hosted? Just like a newsletter? Or like...
So whenever let me see. You know what? Let's just jump into it. I hope I'm still sharing. So I'm logged in.
Yes.
whenever when you're in, you can see that you can view the courses, our standards alignment. Those are our workshops. So if we visit the community, it's bifurcated by lessons and activities, that asynchronous PD that will eventually exist. So when you go in, you can search by high school course, or I also have them tagged to those energy excursion courses, but I know for most teachers, we're going to go to the high school courses. And so for right now, we have 4 main courses: AP Environmental, Earth and Space, Environmental Science Systems, and then Engineering.
So the community is like the display of the resources.
Right. So if I click on one of my courses, and let's see, Earth and Space, here are my activities.
Just wondering, is there a way for teachers to connect with each other in the community, or is it just like?
Not right now. This was completely brought in once I was brought on, and yeah, I would love to get to that point, and that is something on my wish list. Also, my wish list is hiring another teacher to help me with this, but funding. Everyone thinks UT, you have money. I was like, I don't have it. I don't know how it works. But I would love the idea of the engaging in the online with like a discussion board, things like that, but it's not there yet. So right now it's housing the actual activities. So like this, I love this one. Using 4M and IFRA to look at climate shifts over time. This isn't the activity we're doing, but this is something that Hillary developed, and we've done a workshop on this. And so when you open up an activity, it brings you to the teacher document, and it's hyperlinked with things for you to use. I actually created this one to be done in person or virtually. So you can go either way with this activity. But it's basically looking at how the 4M and IFRA form their test, and it goes a specific direction based on the average ocean temperature. And so when you graph it out, you can see an ocean temperature change over time. Students are always asking, like, how do you know about ocean temperatures, blah, 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 blah. Things like this. And since, again, Hillary's a micropaleontologist, so this is something that she pulled from her experience. Hillary's enjoying Wyoming right now. I'm very jealous.
I was on a lot.
Did you do Texas Revolution?
I did Texas Revolution. I did Dig Texas Blueprints project. I did all of it.
Yeah, she probably about 20 years of outreach for Hillary in the department, and she worked to the Bureau and Kathy Ellens, and I met them when I did a workshop. But yeah, Hillary was at the Bureau. She was at the Institute for Geophysics, and so fantastic. And they just wanted a teacher to help them continue this because they'd like to retire. So, but that's the great thing about all of these activities. It's all done in a community of scientists in putting these things together. So did want to show that in our department, we do a lot of research in carbon storage. And to do carbon storage projects, you have to know how to drill. You have to know how to evaluate your reservoir. You have to know how fluids move in the subsurface with the petrophysics. And all of those I work with those different faculty to create these activities like reading well logs. We do a big carbon storage project during our workshop where teachers learn to read a well log and determine where might be able to inject CO2 for long-term storage. And of course, the big upcoming is hydrogen, with hydrogen energy becoming a very big topic in the energy world. You can geologically store hydrogen until you're ready to use it. Petroleum engineers can use their skills in those projects. Geothermal as well. So the one area of focus I wanted to focus was on the geologic storage aspect. So just as a refresher, or just in case not everyone's familiar with CCS, carbon storage and sequestration. The engineering challenge, there's always a fluid in the pore space. Most people don't think of rock having pore space, but it does. You either have water, you have gas, or you have oil, or all three. So if you're going to store carbon in the subsurface, you have to take those things into consideration. But the great advantage is we have so much data on this subsurface rock because of oil and gas that we have data that we can go to now and not have to spend money finding more data.
Is it accessible?
It is. So we do a lot of activities discussing porosity permeability. And I'd say in Texas, 5th through 12th Soil porosity and permeability is a very common topic that's taught. So a lot of our activities dealing with rock porosity and permeability can be adjusted to talking about soil. So that's another great thing of the different activities is it can be applied to other earth science concepts. So we actually have this little model that represents how oil moves in pore space of rock using Orbis and mineral oil. Dr. Masha Prodanovich is one of our department faculty. She does petrophysics, and she created this model, and we use it commonly in all of our workshops. But you could use this to talk about relative density or mixtures, anything like that.
The red platelets and plasma.
Absolutely, yeah. Or I found a way to dye mine burnt orange now.
Yeah.
You know, or UT. But if we're looking at a carbon storage project, we have to evaluate how well or how much storage space do we have? How much pore space do we have? And then will the CO2 move? Because we don't want it to move if we're talking about this as a climate change mitigating project. So this is just a summary of Put It Back, the course that looks at the engineering behind carbon storage. And there's a great case study in there with Dr. Catherine Romanek, who's at the Bureau, and her focus is carbon storage, as well as Sue Havorka. And they actually have some outreach as well called Put It Back. This was a project that Hillary was involved with those people like way back when, I don't know how long ago. So just as a difference is carbon capture utilization. If you're capturing the carbon, you're going to use it for something. You can use it in cement concrete manufacturing. You can use it for carbonation. But for our purposes, we're looking at CCS, carbon capture sequestration. So we're putting the carbon deep underground, drilling a well, or using an existing well that's going to be stored in a depleted oil field or a saline formation, because you can inject the CO2 thousands and thousands of feet underground, have a cap rock so it's not going to escape. So this is where your geology and your data of geology becomes very important if you're looking at putting together a carbon storage project.
Question.
Yes.
5th grade.
That's okay.
So the CO2 storage, where are we getting the CO2 from?
It can be captured at site. So say a coal burning power plant, because they can capture it at the source.
That's your emissions, and you're putting it back into the
into the ground
or whatever,
into the ground or into the rock itself,
and for the purpose of
climate change mitigation, reducing the CO2 present. So you're preventing excess CO2 from being emitted.
Right. So you're maintaining basically that space by pressurizing it with CO2.
Okay. So
I'm with it.
If it's deep enough, I thought I had it, but it becomes what's called supercritical.
Okay.
So it starts becoming between a liquid gas phase. So it's more dense. So about, if I remember right, 7,000 feet down is when CO2 becomes supercritical.
Okay.
And so if it's more dense, it's less likely to migrate through the pore space. One of our faculty is actually her research is focused on injecting the CO2 into basalt, because her research is showing that the basalt composition chemically crystallizes the CO2. So it's not going to go anywhere because it mineralizes. Kind of, yeah, very fascinating. What's that?
Would that be, part of that is the process, of course, the reaction series, whatever, right, that creates the salt. But is it also because it's deeper and so you have higher pressure and higher heat?
I need to ask her that.
I'm just wondering, thinking out there, activating a lot of these brain cells I haven't used in a bit. So
I don't think pressure's a factor.
Okay.
I think it's more of the chemical composition of the basalt. It mineralizes the CO2.
Okay, I'm sorry.
No,
I'm equally
I need a question I can take back to this.
These are like brain cells, like being activated. Do we have a data set that tells us how much space is available for such storage versus how much we are emitting?
That's a great question. That's bringing me to my activity.
Oh, okay.
Watching my eye. Got there. Even if it's something I have to kind of walk through, but I do have such activity.
Okay.
But for the purposes of an easy data activity, the question with students is, well, how much CO2 are we looking to store? Like, how much are countries emitting? Because yes, you look at it at a big scale, but ultimately, if you're talking about a carbon storage project, then you have to think more locally. So I'm starting for this, and let's look at some easy to use data to get students to think about the CO2 consumption. And let me know if you guys can click this. I hopefully made it clickable. We'll force a copy. I'm going to escape because I'm going to click my link if I can find it.
I think you
I'm
might have
sure.
to
I have to put that in the chat because their screens were
Okay.
in Zoom.
So let me do this.
I mean, unless you've opened up the document.
Let me stop
because now
sharing.
hyperlinks are.
I remember the day when you used to be able to hyperlink. Just depends on your settings, I know.
No, I'm just saying the Google Doc that we got a link for, like if you have that open.
No, I didn't have a chance to link it on that yet.
Okay.
Sorry.
I got the slide deck is in there, so yeah.
Yeah, I got I forgot about that.
So I had the slide deck.
Okay, good. Yeah, I did share the slide deck. So if you opened that agenda, you should have gotten to the slide deck. So this is something Dr. John Olson, I have to differentiate. They're married, which when I did their workshop, they didn't clarify. So that was like a really burning question all week. Brother, sister, situation. So now they start the workshop by saying, we're married. It's like, thank you. Like
Everyone wants to know.
everyone wants to know because you have the same last name. So this John Olson teaches our freshmen in the department, and we're petroleum and geosystems engineering. So we have geosystems engineers in our department too. And so please let me know. This is my first go with teachers on this because normally, again, freshman engineering students. But I tried to make it as user-friendly step-by-step as possible. So you're going to complete this activity with some data links, and you can see the first link, the Energy Institute. And for this purposes, I also did some more modifying to kind of direct people. So I've done something like this with my students in AP Environmental in the past. And what I've done is, if I want to do as a class, I could assign students like, hey, you're going to do this country, you're going to do this country. But I could do this with everybody just to kind of go through it. But our first step is we want to look at what is our fossil fuel consumption for the US, for China, and for Norway. So these countries are very familiar to us. Population size, fossil fuel use size. Most people know that a lot of the European nations don't use a lot of fossil fuels. Surprisingly, a lot of them do. Norway actually produces a lot of oil in their offshore. But they are a smaller population, but it's kind of nice to see it just a baseline of 3 countries. You can add more countries if you want, but trying to narrow the focus because, that can just students. So I think, did I open my key?
Yes, you did.
Okay, well, so I tried to make it easy by showing that you would be putting the numbers in the white boxes and then the calculations are done for you. So we're looking at exajoules because that's a unit that's what's used in the department, the students learning about all of this. And on your cut, if it forced a copy, you shouldn't have the answers. Does it have the answers?
No.
Because I have the key to give you later. Because I made a copy for me and then a forced copy for the teachers. So if you click on the link for the data, very overwhelming. So I highlighted real big the sections you will use for this activity. So I know I've already put the answers in. So first, we're looking at barrels of oil per day, BCF of natural gas per day, and exajoules of coal per year, because those are our 3 main primary energy sources for the world. So if you go down oil consumption, I even hid, because it goes from 1965 to 2023, so I hid everything, focus. So basically, you're plugging in the numbers into the spreadsheet. The one thing about this first part, it even tells you, when entering data for barrels of oil per day, be sure you enter the correct value. The little data sheet, spreadsheet, gives your value in thousands of barrels per day, but our table requires barrels per day. So you got to do a little math. Questions on that part so far? And this is a building activity. All right, so We know our total fossil fuel consumption for these 3 countries. That just gives, for those math people and different conversion factors, that's just for your information. So now, chemistry. We need to know how many kilograms of carbon dioxide are being emitted per kilogram of our fossil fuels. It's already been done for you. If it's colored, it's been done for you. This is just a question, a reflection question. So based on these numbers, which fuel do you think is best or worse if we're mitigating CO2? Anybody? What do you think? Who's worse?
Oil's worse. Coal is better. Oh, am I? Oh my gosh. Wait, yeah, right?
I'm so sorry. That was my husband. Sorry for that. Yes, for sure. All right. So, and I also taught a lot of SPED and ESL students. So this is a way for me to also to help keep their focus, try not to get too busy with the data. So again, scale up or scale down as much as you see fit. So we know how much kilograms of CO2 per kilogram of fossil fuels. So now we know these fossil fuels are not the same. In this section, we will again use kilograms for our unit of mass. So if your power plant needed 1,000 megajoules of primary energy, oil, coal, natural gas, which of these fuels is most efficient? Which one? Natural gas. Natural gas?
Yeah, I think so.
Yeah. You're getting more energy for the kilogram, okay? All right. So now, this is where you just plug numbers from above. So these 2 columns, because we're looking for the efficiency number, CO2 emitted per mass kilogram burned, to get our, well, how much CO2 are we getting from the megajoules, the 1,000 megajoules? So you just basically take those values in the blue up and then plug them in and you get your math. So you're getting how much CO2 is emitted for that many megajoules of energy. For that. Okay, so based on which fuel is the most efficient choice for limiting our CO2 while meeting our society's energy needs?
Natural gas.
Natural gas. That's a big reason that our greenhouse gas emissions in the US have actually plummeted so much. The US is basically at Paris levels because we've converted coal to natural gas. That's one of the things we covered in our workshop a few weeks ago. So now, for each country, determine the mass of CO2 using the most current year's worth of data. So once again, your exajoules of year per oil. So you're just going up and pulling those numbers, that 42.39, and you're going to stick it in that white box, which I've already done. And it even tells you how you can copy and paste from above down here. And so when you look at your total CO2 emissions based on the fossil fuel use, you can see it. US, China, Norway. Yeah. But let's take it a step further. So let's look at it per capita. So once again, you have a link to the World Bank website where you can search for the current population of the country. All you have to do is plug that number in and the Google Sheet does the math for you. So if you want to take the math out, you can take the math out, make kids do the math. Other beauty of the Google Sheet. And so you can look at the per capita CO2 emissions and look at the US. It's basically almost double of China with a smaller population. But look at Norway. They have a tiny, tiny population, so you can talk about statistics and all those wonderful math things. Well, you can even go farther into looking at GDP and just tying more elements of global economy and countries into evaluating the CO2 emissions and how that correlates to quality of life, industrialized countries, things of that nature. And then the last part is looking at the percent of their energy mix. So ultimately, China and the US, about 81% of our energy is from fossil fuels. Norway still at almost 30% of their energy is from fossil fuels.
Don't they use wave and
Denmark is the only one, and Scotland, I think, that are testing. I don't know if wave and tidal have been integrated into their energy
grid.
Yeah.
Built at scale.
Scale, thank you.
So Norway then basically uses geothermal at this point? Majority of it?
Yeah, I can tell you in a second.
Still pretty, I mean, oil and natural gas, no nuclear, hydro. Hydro's their big one. And then the link was the same one, the same spreadsheet. And you can, again, go look at any country and see what their percent energy mix is. I will say the data is 2023. It takes a while for this data to become updated, but it does get updated. Yeah. So for right now, for this activity, 2023 is up. Another part of my job is also to make sure the data gets updated with these activities. And then the rest of it is just questions. And so thinking about when you look at the GDP, well, could those countries feasibly afford to do carbon storage, or would they need to do something else? You can get into that aspect as well. Any questions? Larry?
Do you have any part of the activity where you actually do any type of graphing?
I have a different activity. Making sure also, okay. Making sure it wasn't an emergency.
Because the data you have there, you could have them do pie charts and all that other stuff.
Right. Mm-hmm. So let me see. So I'm trying to find the one I actually have done with my AP Environmental Science. I assigned them a country, and it's in a Google sheet, and I have a graph created as they enter the like values like this, except we look at a lot more global countries. And as they're adding in the number for each of the resources, I actually have a bar graph that is created as the data comes in. So I just assign them, like, you have 2 countries to do, here's the link, and then a graph gets created. So then we can look at how the different energy resources vary from all these different countries throughout the world. On the spot, I can't find it, of course, but I know it's there. Maybe somebody here. But I can link that in that agenda that is being shared with you guys. Because it might be part of, for those who teach AP Environmental, Unit 6 is often the unit teachers struggle because it's all about energy and energy resources. And so I created an entire multi-day lesson plan using energy excursions and things I did in the classroom to teach Unit 6. So this might actually be part of that. I'll look for it, Larry, but I do have that.
But what I was getting at is that you can do something like that where the computer does the graphing and stuff for you, but the students can't interpret the graph. So it's like the information that you had with the different countries and stuff, they could develop a graph on their own.
Yeah. Well, we have a design challenge. Oops, I'm totally getting out of where I need to be. In the Energize the Future course, there's a design project where hypothetically the US has gone all EV. You get to decide what the change in energy resources is. It's called filling the power gap. So they do some preliminary reading through what if natural gas, nuclear, wind, solar, et cetera, could fill that gap, because you're going to need more energy if everyone's charging their vehicle. And it's another Google sheet. And this is, again, open and free to everybody. It'll force copy a Google sheet where the students have to figure out what the new mix is. And there is a pie chart that will change based on how they adjust the numbers. Make it a little bit smaller. So the 2040 projections, and then so they play around with like coal's not going to change. You're changing natural gas, nuclear, hydro, wind, solar, because those are the big contributors to our power grid in the US. So the students have to think through it, and then they have to do a mini presentation justifying why they made those changes, because they also have to consider the environmental aspect, the CO2 emissions and everything else.
I'm on the site. Where is the link to that Excel sheet?
So if you go to,
I put could solar fill in the gap.
So go to creating your own energy mix at the bottom. And there's a similar design project in the how much water does it take, where you're considering the water consumption for each energy resource and making decisions on the change or adjustment of the energy mix.
Thank you.
Did you find it?
I did.
Okay. Any questions? Are we have in person or virtual? So this is an activity I will have linked. So this is the hypothetical, and this is a real carbon storage project. So we have a coal burning power plant on the way to Houston called the Fayette County Power Plant. It has been in operation for quite some time. And they're considering capturing the carbon at this coal burning power plant and injecting it into the subsurface, into rock below, not too far away. It's called the Wilcox, which is a known oil and gas producing formation. So we're going to learn to read a well log, to see if this subsurface geology could possibly store carbon dioxide, because this thing's not going away. It provides a lot of energy for Austin. Like, the city of Austin owns this power plant. It's part of the Lower Colorado LCRA.
Yeah,
River Authority. Thank you. All right. So for in-person people, I have a copy. There are some great maps at the Bureau's website that you can print for free. So Texas has some very unique geology. But what has Texas been covered in many, many times over history? Water. So we have a lot of sedimentary rock. And I realized the one thing I didn't emphasize, sedimentary rock is where we're targeting to inject CO2. Because sedimentary rock has pore space. And there are sedimentary rocks that don't have very good permeability. So there are some great sedimentary rocks deep underground that can serve as a place to inject not just CO2, but maybe hydrogen. I learned that the city of San Antonio injects extra water into the Edwards for storage until they need it. I had no idea. Like, that's kind of cool. I don't know any more than that, but Hillary found that out. I was like, oh, very interesting. So here's Austin. I know you're people on the line, a little different. So the Lower Colorado, the Fayette County is down this way somewhere. So it's this formation here that we're looking at deep underground.
You might want to point on the computer, your cursor.
Do I have a little?
You do.
Yeah. Person. Yeah.
Right there. Yeah, so
We're
that the
seeing-
online folks know where you're pointing.
It's the pinkish one called EC2,
Yes, thank you.
but also move your mouse over it on the screen so that
I don't know because it's so hidden with that white arrow.
Yeah, but it's
Yeah.
showing right
But
now.
it's
we
showing.
Green button.
yeah.
Doesn't look the same on mine. Okay. So this is the region that we're looking at, but lots of great things you can do with geology maps in different classes. I like to talk with my students about how the different geology is what sets the tone for your soil formation and all of that good stuff. All right. But nationally, the Gulf Coast has been very well backed in research for carbon storage because of those different sedimentary rock formations in the subsurface. So, students often don't understand how much goes into engineering for different projects. There's a lot to consider, and it's very multidisciplinary too. So first, if we're going to look at storing CO2, do we have subsurface rock that has enough pores? And I wish I could do this in person because I have some hands-on stuff, but come to my week-long workshop. Then, is there a cap? Is there a rock that will keep the CO2 from migrating and seeping out? Deep enough, as I talked about, is super critical so that the CO2 is becoming dense enough for limiting that migration. Is there enough pore space? because you have to calculate how much CO2 is coming out of that power plant every day for a year. How long do you have enough rock for long-term storage to continue to inject? And then you also want the formation to be relatively close because you're spending money, transportation, more emissions to get the CO2 to the location to inject. So that's also taken into consideration. This is another exercise that's done in one of our freshman engineering classes. So here is a well log of this formation. Has anyone seen a well log before? Hey, yes, thank you. Sorry, virtual people, in person are getting a little copy, but I hope this is big enough on your screen. The great thing for us is that a geologist has done the job for us of identifying our subsurface face seeps or rock formations. And what we're looking at, this is our relative permeability and our relative porosity. I will say I taught this wrong. I always told my students if the grain sizes were big, porosity and permeability were automatically high. Not true. Because clays, shales, have a lot of porosity, but the pores are not connected, so your permeability is very low. So it's all about how your pore space is connected in that subsurface rock. So sedimentary rocks essentially form from clay minerals, which are flat, or like sandstones, silicates, that are a little bit more rounded, sometimes well-sorted, not very well-sorted. And those environments, those types of rocks are created based on those marine or we'll just say aquatic environments. So since we know this formation was from a coastal area in Texas, by the way, this is starting at 7,000 feet down, so we're already over a mile down. So you can see how the rock changes with depth. The red line is our baseline of permeability. Yes. So the relative permeability that's to our right is what we are looking for in our rock. And if you look at your porosity, going to the right means a slightly higher porosity. Does that make sense so far? Maybe. So we want to see where in our formation do we have good porosity, but we also need decent permeability because we need to get that CO2 moving into the pore space. Not so much that it'll start leaking, but enough permeability so that it can actually fit. We can get it into the pore space. So as I said, Wilcox, oil and gas, we had a lot of data about it. This was taken from a core, which nice big circular pieces of rock that they pull out and they cut them in half. So your handout is showing a well log of a core. So we're just becoming introduced into what a well log is. We use gamma rays to measure the radioactivity, but that also tells us the type of rock, which can indicate what our porosity and permeability are. These dots for porosity and permeability are just a relative average at those sections of the rock. Please tell me if you have questions or if I'm going too fast. Oh, that's just talking about in the middle. It's kind of tiny, but it says permeability and porosity at the very top. So those two properties are important. Okay, so let's get acquainted with our kind of target zones, if you will. We're primarily looking at our channel mouth bar and our pro delta. Which one of those would be good for injecting and storing CO2? So a pro delta has coarse sand and sediment built up when river channels are entering a big body of water, and your pro deltas are fine sediments, silt, clay, etc. So basically, one's good for storing, one's good for a seal. So which one do you think would be good for injecting and storing something in the pore space?
Channel mouth.
I've got a vote for the channel mouth bar.
It has my vote.
Has your vote? So how many injection zones are there in this one section of the Wilcox?
Two.
Two?
Oh, no, sorry. Three.
Three?
Oh, I didn't even
Three.
see that one.
Vote for three? Do those injection zones have a cap or seal to keep CO2 from migrating?
Yeah, wait, at the very top,
Yeah,
the permeability is under that line.
Yep.
So that's a good thing.
right, because it's not going to move. So it'll keep it from moving up through that rock. Yeah. We did that part. Okay. I'm just going to skip through this. We just did that. So we have 4 sections in this particular formation where CO2 could be injected. So our delta fronts, our pro deltas make the cap seals, but our channel mouths are the CMB. It was really small down here. Yeah. So we have those sections. Okay. So it's just one piece of data, but we have an idea. Yes, ma'am.
Is that the bottom part? Is that worth going that deep? The 10 feet, is that worth it?
Because it's part of your volume. Because you're going to need a lot of pore space for all that CO2. This isn't they haven't started work doing this yet, but this is a real consideration for this power plant. Well, okay, so we have rock that looks good for storing. Well, how much CO2? If we know how much a power plant is generating in energy, we can calculate these CO2 emissions. So bringing in some math and dimensional analysis. My kids really hated it. I loved it. Dimensional analysis. All right. And you have the key, you'll receive the key. So again, you can scale up, change, however it would fit best for your class. But first, if we know our rate, basically how much energy the power plant's creating, out for a year, so that's how many joules of energy this power plant generates in a year. That previous activity where we looked at energy consumption and then how much CO2, that ties into this. Already becoming familiar with the fact that if I burn this much natural gas, I can expect to get this much CO2 emissions. So now, well, if we know that this power plant's only 50% efficient, well, that's how much coal I need. So we have our energy. Well, I need this much coal for the year to run this power plant. So then how many tons of CO2 would we expect to be emitted? So that's how much CO2 in a year we need to store. Is that a lot?
That's a lot. That's a year.
That's 1 year of CO2.
1 year.
This power plant primarily burns lignite, or it might be sub by 2 minutes, but it's on anthracite, which is the best one. So let's talk about scale. I've done the math for you. This project would need 206 wells injecting daily to store the carbon. Well, is that a lot? So in the state of Texas right now, there are 315,618 active oil and gas wells. There are 34,200 disposal wells. So wastewater from industry, whether it be oil and gas or anything else, they inject it into wells in the ground.
Right. Okay.
So disposal wells.
So is that what we're trying to replace instead of water? We're trying to replace it with carbon dioxide.
Well, no, this is just, we're going to still have those. As long as you have industry, because whenever you produce oil and gas, you're getting water.
Right.
Because there's saline water in the formation.
Yes.
And so that needs to be disposed of, except now they're starting to reuse it. It's called produced water. They can actually use produced water in the industry now without needing fresh water. So that's a big engineering change in recent years where the different.
But is the goal for those disposal wells to be sealed with carbon dioxide?
No, this is just what we have now. Just giving perspective, is 206 is okay. Drilling 206 wells a big deal?
Yeah.
Is the answer no?
No.
No. Not a big deal.
Very tiny.
Yeah, in the grand scheme. It was amazing. I went to Carlsbad Caverns for the first time recently. And in Carlsbad, like, new oil and gas absolutely everywhere I look. was wild. I thought it was in Midland. It's crazy. Okay, so not really that much, but how many acres would that be? 206 wells would need 81,000 acres. Well, is that a lot of land? That's about the size of Lake Texoma, which I circled on the map. Because that's another consideration. If you're drilling wells to store carbon, well, what's the footprint? There's in the actual activity, you can have your students get to this with math. And it's all built with dimensional analysis. For our sake of our time, just kind of like touching the highlights. But again, scale up or down as you see fit. Washington, D.C. is only 43,740 acres. So your 206 wells would be bigger than Washington, D.C. I love that. Texas, 172 million acres. If you teach AP Environmental, I have a pre-response question that I integrated the carbon cycle with carbon storage, and the rubric is with that. I don't know how many AP Environmental science teachers we have, but this can go, or if someone wants to chunk it out for different content areas, you can use it for that. Just kind of getting kids to reflect on and tying all these different earth science concepts. There's also an article that was done where you could do a town hall meeting or some sort of Socratic seminar, because it has been a hot topic with still having coal burning power plants nearby. And then, the conundrum of energy needs versus changing out the fuel and things like that. Okay. I know that's fast and furious. Any questions, anyone, online or in person? Yes.
Have you, so first of all of these projects, are they all, you said they're all targeted at secondary, right? Have you had anybody try and like adjust any of them down for like elementary?
Not yet.
I'm thinking
I would love to.
Grade. And I'm also thinking about maybe like your accelerated, like compacted curriculum classes,
right,
like fifth, sixth, like we have 5, 6, that kind of thing. And I'm wondering, I don't know, it might be something where we start using Gemini to kind of say how might you.
Right. And I would love,
that might.
So the past 2 summers, there is a Consider Every Option, which is an engineering camp put on by Women in STEM here at UT Austin. Mm-hmm. And they have a sustainable engineering camp, and those kids have done a different carbon storage where we actually have the core in our core lab. So they read the well, and we teach them how to read the well, and they're doing it with the teachers. So we know that this can be done in high school for sure. But yeah, I would love to be able to scale it down in different ways for elementary.
I'm wondering. I mean, I would share this with. I mean, I have lots. I know high school people and middle school people in our district, but in my current role, it would be nice to be able to say, hey, how could we take one and scale it down and then try this so that they see more of that, because that is where we have a lot of lack. Mm-hmm. And I think something like this, where it's so engaging and is so pertinent to their state, like that's really a huge connection piece. And the fact that they struggle so much to make sure that they're getting in that social studies piece, and that could be part of that geography. Yeah,
definitely cross-curricular. So, and another thing we do with this, we actually have sandstone and shale pieces, and sandstone will imbibe, which is basically what roots do for water in the soil. So we set the sandstone in water, and it just that capillary action. So you can even bring that in, like, because students are like, oh, rocks don't have pores, and just see the water, and they're like, oh. And that's kind of like an intro that we do with this when we're talking about putting a fluid in pore space of rock to kind of like, you can see it.
Right.
And you can do that with, because the students have a really hard time at 5th grade level understanding volume and volume displacement. So when you measure before and then after you place the rock, and then it sucks up, right? Everything, and then you measure the actual volume of the water. You can actually have them see that the rock, where did the water go? Or where did that liquid go? Or like it's still in the rock. Now it's in the rock.
And so we actually have a little intro activity called Pack It In, where they make their own packing of just different size marbles, and you measure the volume of the packing.
Yeah.
It's in one of the.
Yeah, I think I saw it when you were scrolling.
Yeah. It was actually in an NSTA article that I did with Dr. Karanovich last year. This one. Just real simple, just different size marbles in a set cup. and you can do a porosity volume with just showing how different packings can affect your pore space. So I will be in Midland. I know that's not attainable for everybody in September. And this is part of the West Texas Geological Society and Southwest Section of AAPG's conference. And it is a K-12, more earth science type workshop, but we do integrate the energy resources with it. And again, it's in September. It's a Saturday. Meals are provided, CPE hours, just that's coming up. If you happen to want to go to Midland, Texas.
Still link in the chat.
You have the whole presentation there. Oh,
Yeah, the whole presentation's in the agenda that was given to you, and this is all in there. Of course. And I have my card here. You guys can take it and you can welcome to email me. I will say, unfortunately, our week-long workshop's only for Texas teachers. That is very specific with my funding that I get for this workshop. But if you're from Texas, middle school to high school, we're going to be doing this next summer. Everything's paid for. You stay at this hotel, the AT&T. As of right now, we'll see how that goes. Had some bumps, challenges this year. But the first 3 days are spent here on campus, and all of our faculty are doing the teaching. So you're in labs, and we will be in our new building next year. But we have 2 different buildings and laboratories that we go into. This is where we were doing the mud lab. So Hugh Daigle actually is in charge of our research center. So all of that research topics I showed earlier, that's housed in our research center, and he's in charge of that. We're also doing more with Dr. Michael Weber, who's in mechanical, but does a lot of documentaries and outreach with water and energy. His new one is coming out on PBS soon, but he also has things posted in the PBS. But his focus is the water energy nexus, but this talk was also more about hydrogen. His research group's doing a lot about hydrogen. So yeah, I will open the applications in November. I'm also, for those in Texas, a TAC provider, the environmental education, kind of like an accreditation you can get as a teacher in Texas. $200 stipend for attending. And then I also have a reimbursement stipend to help offset cost of getting to Austin. We do go to Houston on Thursday to go to an industry visit. We went to ExxonMobil this year, and then we go to the Houston Museum of Natural Science to the Weiss Energy Hall. Then look it up. We stay at the Tremont House in Galveston, which is a very nice hotel in the historic part of Galveston. And we go to the Ocean Star, which is decommissioned oil rig. And that's kind of how we round things out. Then we get back on a nice charter bus with a bathroom to head back to Austin. And then I always have to share with Tamara. So this has been around for 40 years. Been around. It started as a university workshop for lower university students, but now it's for teachers. So we have 4 workshops. We have 2 that focus on coal mining, one in the Bryan College Station area, and then one in San Antonio, San Miguel, and Costi.
Oh, did they not do it near Jewett anymore?
Jewett. So funny enough, we go. Jewett's closed. Jewett's in full reclamation.
Oh, okay. Okay. But, yeah, I think they'd started the process when I went.
Right. And so now with Costi, which is the one in College Station, Bryan, we go to Jewett after going to Costi to see the reclamation. And there's a local garden that all of the produce goes to local food bank.
Nice. And
they're increasing how much they're producing out of that garden on the reclaimed land. So just tying in all of that, local response. Yeah.
One of my teachers that I support got into the Florida coal camps this summer. So she went to.
Who was it?
Nora Isaac.
She must have been at San Miguel because I worked at Costi.
I can't remember which one she told me but I gave her this information and the McDonald's, or she got.
Oh yes,
she's my sped science teacher at one of the schools. So yeah,
this is open to teachers throughout the U.S. Yeah. I will say you have to get yourself to wherever the location. Uranium's in Corpus Christi. Everyone thinks, "Ooh, uranium mining, so cool." Mm-hmm. It's in situ, meaning they're bringing water out of the ground that's full of uranium and they're getting it out. But it's now in production, and we do get to see uranium cave. We just can't touch it. Mm-hmm. And the nuclear power plants are just a no-go now. You don't get to go in, and driving around them from the outside is just not very exciting. So we have a lot of presenters come in to talk about the uranium mining and nuclear industry and stuff like that. And then industrial minerals is in San Antonio as well, and it's all about the concrete aggregate industry, which is huge in Texas. But once again, free. Our booths will be next to each other. We're always next to each other at the Texas Science Teacher Conference. But again, these are open to everyone in the country. The Bitly just takes you to their page, so save it whenever the new year, the new summer stuff becomes updated. That's where it will be posted. All right. Yay! Actually, 15 minutes early.
That you wanted?
Yeah, these are just handouts about us, energy excursions, and then my card if you want to reach out to me for anything. Feel free to take you as you would like. And for everyone online, feel free to email me if you have any questions or need help with anything you can't access.
You can go back to the agenda page and just move it here.
Okay, closed it. Let me stop sharing for a moment. Lost. So I'm gonna go to the chat. There we go.
Yeah, it's not the landing. That's not the one. We want to go to the one that is.
But if you go to go to the document tabs and go to the first one, and then go to that old link.
The Bitly that was put into the
Was just this.
is this. So this is the place that we want to be. And if you could scroll down a little bit.
Sure thing.
So just we're going to be breaking soon for lunch, but we have a little assignment for before you come back. You're going to go ahead and click on make a merge paper cube. If you are online, you will need to print out, scroll down. Print right there, download the paper cube and print it out. If you have the ability to click that, please, to print out that page, you can cut it out, fold it up, and make a little cube that we are going to be using in the next session. I have paper sheets here. And I have little Boston cubes for the next session. It won't be the first thing. I have scissors and glue. So sometime in this lunch break, if you have few moments to cut out, glue up, and have a paper merge cube, this will be part of the next session here. The first person to speak will be actually Ashley, and she will take you to some My NASA data activities.
Thank you.
And does everybody have one of the paper thing?
We're getting there.
So essentially, you're going to cut it out. It's a 6-sided thing. You're going to glue it to the cubes that I just gave you.
Did I get a cue?
Oh, Lori didn't get a cue.
Oh, you can.
I didn't think so, Larry.
He's got one now.
He needs one out. He just gave.
Dawn already has cubes too. I mean, you've made them. But I have scissors here. I have glue sticks. There's a bunch of glue sticks. So just there, sometime before we start up again, because we're going to have a nice big break for lunch, just please cut out and glue up. Cube.
This one here,
Yeah.
is it safe to leave our stuff in?
I'm going to ask because there was like some theft thing that happened, but it was a main, in one of the rooms, but it was a main computer. It was like something done after. It's not good, but I don't got it. Yeah.
Jump ahead.
Yeah.
Do you want me to read this out or is that gonna take a much?
Yeah. Oh, no, then you don't need to.
So what do you?
How do you get these besides just, I mean,
download
Did you see the link there?
Yeah.
That we went off of the agenda? And also it was off that agenda page, which we'll bring up again at the next thing. There's a link to this page so you can print as many as you want to, but they also sell.
Yeah.
Tell them the next.
That was very cool.